Welcome to ORA Shorts and a very happy Earth Day to you all, wherever you may be. We hope you are well and safe and busy, and thank you so very much for joining us. Today, we're going to examine the intersection of energy codes with track lighting solutions. Track lighting, so simple, solves everything. And if it doesn't, just twist it off and move the track head. What once was such a simple solution for retail, hospitality, residential, you name it, applications, has become a little more complex, and it requires a little more engineering. We are going to show you straightforward methods you need to take advantage of track and still meet the code. After that, we're going to get a peek at current limiting solutions from Lumenture Lighting, as well as an update on their newest products. With us is a particularly special guest, Marty Salzberg. Marty was an award-winning architectural lighting consultant for more than 30 years, designing mostly institutional projects like performing arts centers, libraries, schools, hospitals. She teaches lighting design at the New York School of Interior Design, and she has done a great presentation for the New York City Energy Code at Leducation. She's active with the IES and the IALD and currently serves as the ASHRAE IES 90.1 Code Committee. In 2015, she was honored with the IES NYC Brilliance Award for her dedicated service to the local lighting community. We are grateful to Marty for being here with us today. At the end of Marty's presentation, we will have a Q&A session as usual, so please drop your question into the chat bar. And then we'll meet with another familiar face to ORA Shorts, Peter Colman, from our manufacturing partner at Lumenture. And we'll have some more track talk. After his presentation and Q&A, we are going to reveal the third and final design firm's project in the ORA Odyssey. So please stick around for that as well. All right, let's get started. It is my pleasure to welcome the New York City lighting maven, Marty Salzberg. Welcome to ORA Shorts, Marty.
Thank you, James. Let me set up and share my screen.
You go right ahead. I'm gonna put this to you, Marty. For decades, the design community has embraced track lighting. It's flexible, it's easy, it's generally less expensive to install than downlighting programs. But at some point, the energy police just had to step in and set some limits. Would you please cut through some of the code language for us? And are the ASHRAE and IECC codes even on the same page?
Well, that's what we're going to talk about. Thank you, James, for that great introduction. And thank you to Oblaney Rinker for inviting me. Can you see my screen okay?
We can.
Great. Most energy classes try to jam the entire energy code into a 60-minute session with too much information to digest all in one time. Today, we're only going to look at one section of the code, how to count the watts. There are two model energy codes in the United States. One is called ASHRAE 90.1, the other is IECC. ASHRAE 90.1 2016 and IECC 2018 were the basis of the New York City Energy Code, which is in use right now, the New York City 2020 Energy Code. How we count the watts is the same for New York City and in New York State. New Jersey and Massachusetts also use these versions of the code. Other states are using earlier codes, so the information we're going to discuss today might not apply if you're working outside the ones I mentioned. This link at the bottom of the page will help you find which codes are used elsewhere. Now, why are we going to discuss both codes? For the first time in a long time, the way the watts are counted is not the same. Total connected lighting power is determined by adding up all the watts used on the project. Each type of light fixture has a defined method for counting the watts. This is the code language in ASHRAE. The pages of this presentation are color-coded, blue for ASHRAE and green for IECC, with a code book icon on the page to remind you which code is being discussed. IECC has written these code requirements as a formula. Dense code language like this makes everyone's eyes glaze over. Let's break it down by the categories and compare ASHRAE to the IECC requirements. In ASHRAE, a line voltage fixture without a ballast, no transformer, no driver, like this one with 2 medium base sockets, is counted as the manufacturer's maximum labeled wattage. This manufacturer says each socket is safe to use with up to 200 watts. The luminaire would count as 400 watts. The specifier can ask the manufacturer to provide a wattage restriction label on the socket so that the maximum wattage counted is lower. This LED lamp is roughly equivalent to a 200-watt incandescent and uses only 25 watts. With a wattage restriction label on each socket, the luminaire now counts as 50 watts, not 400 watts. In IECC, the equivalent portion of the formula is the requirement for LVL, luminaires with line voltage lamps. New in IECC, we count the rated wattage of the lamp, not the luminaire, which is, as we've already seen, it can be a huge difference. In this example, each socket is rated at 150 watts. With 20 sockets, the fixture would count as 3,000 watts. With 20 LED lamps, each at 10 watts, this chandelier would count as 200 watts with or without a wattage restriction label. In IECC, we count the watts of the lamps. When the fixture has a dedicated ballast, driver, or transformer, ASHRAE says count the wattage of that device, or the maximum wattage labeled by the manufacturer. In ASHRAE, this covers both LED and legacy sources. In IECC, BLL is the portion of the equation where we count the rated wattage of the dedicated ballast or transformer for legacy sources. For dedicated LED fixtures with either integral or remote drivers, IECC says count the wattage, the rated wattage of the luminaire. When counting the watts for track, ASHRAE separates line voltage from low voltage. For line voltage track, count the wattage of the luminaires used, or 30 watts per linear foot of track minimum, whichever is greater. Alternatively, count the watts of a circuit breaker or a current limiter. So a current limiter scares some people, but it's really a simple accessory included in a track installation that restricts the wattage that can be installed on the track, protecting the system from overload, usually by turning it off. ASHRAE specifies how to count the watts on a low voltage system separately from line voltage. Always count the wattage of the transformer supplying the system. Track is another area where the IECC method of counting the watts has diverged from ASHRAE in the current code cycle. For track, similar to ASHRAE, you can count the wattage of the luminaires specified for the track, but not less than 8 watts per linear foot of track. Remember, ASHRAE counts 30 watts per linear foot. A current limiting device restricting how many watts the track can accommodate might still be desirable for long runs of track, but is less likely to be necessary to meet the IECC code path. For low voltage track systems, you can count the wattage of the transformer serving the system, But best practice would mean that the watts of the luminaires would always be less than the capacity of the transformer. And in IECC, you can still count the watts of the luminaires as your path. If the project has other luminaires not already described, both codes have an other category where we are directed to use the manufacturer's specified wattage. In summary, when counting the watts, there are two good reasons to select the IECC compliance path. First, that for line voltage fixtures, we count the watts of the specified lamp so that we might not need a wattage restriction label. And second, the track is counted as 8 watts per foot, which might preclude the use of a current limiter. However, there are two types of projects that must use the ASHRAE compliance path. Projects seeking LEED certification use ASHRAE. And in New York City, if a project is large enough to build a whole building energy model, you must use the ASHRAE compliance path. I hope you now have a better understanding of how to count the watts. James, back to you.
Well, definitely a better understanding, and I think it seems to be a moving target with the energy codes, of course, and having coordination within the team about which codes you're designing to is key to the success of it as well. There is one question currently in the queue right now, and I'm going to get to that as I move this. When did the most recent code go into effect? The code you just discussed?
Well, it went into effect in May of 2020 while we were all deep in isolation and not paying attention. And that's because it was determined and it was agreed in December of 2019 that this would be the date that it went into effect. And once these things, once the train starts moving, you can't stop it. So it happened, and a lot of people were caught unawares because people sort of were doing a little bit less work in May also, and then they came back and started new projects, and here was a new code.
And Marty, current limiters, unlike track heads, are fixed in position. Is that correct?
That's right. It's an accessory and it has a connector, just like you were continuing the length of track. You just slip it into the track and it becomes the feed on your track. The line voltage goes into the current limiter, and then the current limiter is connected to the track, and it prevents too many luminaires from being attached to the track.
Got it. And it doesn't impact any dimming or any of the emergency requirements that are typically in the system. It's part of the system as a whole and functions in accordance with the design in that respect?
Yes, it does.
And another question was, with tech getting better in LEDs, will this change drastically in your opinion? With the sort of efficacy of LEDs and energy consumption still being of high value, but if you're able at a certain point to start getting 300 lumens per watt, will it matter as much to have current limiting devices on the track, I think is the question.
Well, IECC has already adopted this reduction in how you count the watts as 8 watts per foot, and that's really an acknowledgement of the efficacy of LED. And in my privileged position at ASHRAE, I can tell you that that proposal has also gone out for public review to be incorporated into the ASHRAE code compliance path, but it won't make it into ASHRAE until the 2022 version of the code.
Okay. So we're still gonna incorporate and embrace it. Remote current limiters, still an option, correct?
Remote current limiters that reside like on the circuit breaker panel are, yes, they're still an option. I only show the ones that are on the track because As a lighting specifier, lighting designer, I'm never the one who specifies the ones that reside at the circuit breaker. That's an electrical engineering problem.
Ah, gotcha. Okay, got it. So good to know. It might be that if it's not shown on the architectural drawings, one might also check the electricals to see if they're inclusive in a lighting panel.
Right.
Okay, terrific. Um, well, one of the comments is that that request comes often on most projects from one of the designers with us this afternoon. It just allows for the installation to be cleaner as you don't see those devices on the track. I think we're all in agreement with that, Daniel. If we can avoid putting them out in front of people, all the better. And I think that wraps up the Q&A portion of what we are into. Marty, thank you so much for helping put a face on it. I think that makes it all much more accessible to us. And we're going to look forward to bringing you back, hopefully in the near future, to share more of your wisdom and education with all of us. So thank you again for joining us. And now you get to see, as we do, where we are going to go. And now we are excited to see what's new with our manufacturing partner, Lumenture. Lumenture brings together innovative technology and thoughtful design to blend into any environment. And Lumenture brings us that sparkling pixie, Peter Colman. As VP of Sales, Peter drives all sales efforts, drawing on his 17 plus years of multi-channel lighting professional. He has worked here in New York City and across the US, then in the Middle East, Central Asia, and the Asia Pacific region as well. You are welcome back to Aura Shorts, Peter. Let's talk track.
Wonderful. As always, thank you very much, Mr. James O'Blaney and the entire ORA crew, as well as the very informative Marty.
Yes.
Latest and greatest with code. So we're going to try to dovetail exactly what Marty had discussed and see with some real actual product what's going on and how to integrate that.
Let's do it. Thanks.
Thanks so much. So with that, we're a track and downlighting company. We're headquartered out of Connecticut. And what we've done is tried to aim for the smallest, most compact, highest lumen output that can actually arrive onto a job site within budget. So what we're doing is streamlining all cross-spectrum categories. So project installs of retail, commercial, galleries, hospitality, and we're pretty much cross-spectrum regarding key runner fixtures. So track heads, wall washers, both point source wall washers, track infrastructure itself, recessed wall washers, and downlights. To mention a little bit of where Marty had described the two different modes of thought regarding IECC and ASHRAE. So the top line 30,000 foot view, current limiting is required, or at least giving some accuracy to how much actual current or power is being used. And you're doing that with the current limiter. And then the second is a per fixture label. So to dig into some of that actual detail, looking at real product of what it is, here's what Lumenture is currently offering in terms of current limiting. So right here, what we've got is the actual physical current limiter itself and the details of what that is. So why this would be used and how. NEC is basically allowing for 1920 watts for a run of track, regardless of how many fixtures are actually going to be on it. Regarding specifically ASHRAE, we could put on a current limiter, which the one I'm displaying right now is an end feed. So what it is in an actual physical form is literally the feed that would attach to the run of track itself right here. And then what we're doing is feeding it instead of what would be a normal feed. You would actually attach that. And this right here is the actual breaker itself. And the current limiter and the actual breaker is what's going to be rated for how much actual power is going through there. So for example,
and that rating, by the way, Peter, not to interrupt, that's usually designated by the electrical engineer, correct?
Correct, exactly.
Thank you.
Yep. Exactly. And that's a very important part of this to say, okay, what's the actual ownership of who indicates that and basically specifies what that is. So what we're assuring by putting a breaker on there, and the range can be from only a half an amp all the way up to 12 amps, is that it's getting very close to what's actually being used on the track. So for example, add a 25 track fixtures on there at 18 watts a piece, 450, a 600 watt current limiter could be used. And then with that, it's getting much closer. Regarding IECC, it's a per fixture label, so it would get even more accurate, being that if it's an 18 watt fixture, that the actual label of the fixture itself shows 18 watts. That's the entire allowance of what that is. So it's interesting. And then in terms of the different types of current limiters, there's inline, end feeds, and then a slim end feed. So with that, I can jump over, if there's not any questions, I'll over to what's a little bit interesting regarding what we're doing for wall washing. One of the examples that we have, and just in its most compact form, what we do is we aim to have the most minimal packaging, so 100% efficient. We've all got those Amazon boxes that has a spoon in it that's a 2-foot box, and there's a tremendous amount of wasted space. So we try and be as efficient as possible, and it allows us to inventory more and have a quicker delivery. So with that, on the wall washing side, what we're able to do in a very small compact form factor is out of 1600 lumens and a very minimal footprint on the ceiling itself, be able to deliver a very even wall wash spacing. And then if we can actually dig into the details, you'll see the different parameters indicated here. So at a 60-degree, 40-degree, even 35-degree angle will show on the next slide, and then the spacing criteria. So the overall goal is to get as much even illumination, evenly spaced, uniform track fixtures on the actual track itself, and then the max to min ratios of the foot candles as uniform as possible. So with that, there's been a tremendous amount of installs very simply regarding a standard point source fixture and a wall wash fixture. And what's interesting about that is we're doing one layer of light with the wall washer, and then with the point source, we're being able to accent at a higher lumen level. So whatever these foot candles are, if we add accent point source track fixtures to that, we're now going to raise in a very specific area that foot candle level. Well, moving on to that, some unique design installs require actually only a cylinder-esque form factor fixture. So what they've said is, okay, we understand the wall washers, we really appreciate what that's doing. However, for this install on this design aesthetic, we only want cylinder-esque fixtures. So what would then happen to the wall washing? What we've developed, and we're going to be coming out with, is a TWW or a T80 wall washer that is going to essentially have a point source and wall washing capability. So with that, an example is from the optic itself, what we're doing is changing the distribution of what would normally be a standard point source beam, but we're now spreading it out to create an actual wall wash effect through the beam bending, saying, okay, we're now changing that distribution to narrow, from narrow to wide. It's interesting just in terms of the whole spectrum of what's available for wall washing and then point source. So a little bit to that, we can talk about the actual portfolio itself, which is interesting. So as I mentioned before, we're trying to have the most compact, minimal form factor, so no protruding edges on the fixture itself, yet the versatility of what is afforded on a track head, a center pivot point SEM with the fixture not having the exit out of the back. It'll be a completely uniform install on the track itself, regardless of aiming angle. It's also interesting because of the half size track adapter. And with that, it can accommodate J-type track, H-type track, L-type track, and then also global track, which is a 2-circuit, 2-neutral system. So with that, it's a line voltage 120 volt fixture and infinite rotation without any exposed hardware, So with that, for the projects that require aiming and focusing, it's going to be obstruction free to assure that the light is exactly where it needs to be. We're also paying attention to shielding and very specific characteristics of lighting design. by allowing for full accessories. It's a threaded front. So with that, we're able to go for a tapered snoot, for example, or a straight snoot. A lot of questions come up about the straight snoot or tapered snoot to say, is the inner masked? So it would be glare free or flash free on the edge of the lip. Some kind of details there that pay attention to minimize any potential glare. So we try and have the fixture aperture be as quiet as possible. Also worth a mention is with each accessory and fixture, you have at least one accommodation of a thick accessory, and then at least two of the thin film diffusion accessories, so a linear spread or some sort of color gel that's available. So with that, some interesting installs that we've had. This is the W Hotel in South Beach, Miami. It's a very nice install. This is Major League Baseball flagship right across from Rockefeller Center, which is interesting. What we try to do is pay attention as easy as possible. We understand deadlines to make sure that our website is a 2-click website to get you exactly what you need for the spec sheet. You'll notice on the first page of every spec sheet, it's the complete catalog number. So we do this by design to give you the full breadth of what characteristics are available without needing to go to the subsequent pages. With that said, all of the subsequent pages go into those details regarding the actual candela curve, the different color temperature, multiplier levels to see how much light is actually getting out of the fixture, and then the last page having all the different accessories and the tapered snoot and whatnot. So the T65, you'll see right there, it has a beam angle range all the way from 10 to 60, and everything that you're seeing here is also available in dim to warm. We're not limited by any of the available color technology out there, so you'll see listed on some of the spec sheets an actual plus 95 CRI chip. So we want to pay particular attention to that. So with the fixtures, we're also a full breadth of the range into downlights, which is interesting. So with the downlight range, we had originally had our DL100 series. Give you an example of where we had come from. So with that, we have a little bit of a thicker flange and a little bit of a wider flange as well, but you'll see a very nice shield hood there. So to assure that there's not going to be any refractivity going on into the plenum itself, and then a nice clean shaved heatsink. So with that, great, there was a question that popped in, and we can kind of address what that is. So on the dynamic white side, it is 1800 to 3000. So in terms of our Warren dimming technology, it is going up to 3000. Thanks. We're trying to go for that, and then actually, depending on the scope of the project, we can also look at other LEDs that are out there. So if there's a range that you don't see, we can go for it. We purposely, by design, actually put a static 1800 color on our 2200K on our spec sheets as well. As a standard, our CRI is plus 90. So what we do is we make sure that's everything in inventory itself. So actually everything that you've seen here is fully inventoried in Connecticut. So we're able to, we don't have a formal quick ship program, but we understand the needs for small quantities on quick turn projects. So we've been able to accommodate what that is as much as possible, which is interesting. And then to further the actual range itself on downlights, we've gone to what is now, what would have been a wider aperture, now to a DL 75 series, which we've done is take the actual aperture and then shrink it down, but a smaller flange, you'll see, nice deep regress cone. And then with that, we've gone further to a more narrow and smaller aperture series, which is our DL 60. And here's an example of the DL60. You'll see a nice deep regress cone, a very, very thin flange, much smaller in terms of its impact on the ceiling, but full shielding available with a nice deep regress cone, so glare free. And then it's a full range of a family. So we have the static or the standard fixed. Then we also have the adjustable with that. You'll also see on the adjustable the glare shield as well to assure no flashing regarding inside of the fixture itself or in the actual housing itself. And then to that point, we also have squares. You'll see the squares, and then also, and most interestingly enough, the flangeless. So we have a very rigid and secure spine flangeless. It's not a piece of plastic that would have potential waves in it. So it's something that's going to sit very sturdy on the surface of the drywall to make sure that the rigidity over time is going to be maintained. And with that, on our spec sheets, it calls out all of the same characteristics that you would expect, specifically regarding the overall depth. It's the most minimal as possible in the ceiling. Dimming protocols, we are standard ELV and TRIAC. On our website, you'll be able to navigate to the downloads page and see a full dimming compatibility matrix chart, which actually calls out Leviton and Lutron dimmers and catalog numbers, both pre-programmed from the factory and then adjusting a low-end trim in the field. So what we're trying to do is really pay attention to some of the easily forward-ontable an engineer to assure that dimming compatibility would be within expectations of the spec. So with that, every spec sheet of our new DL60 and DL75 and current DL100 fixture series, on the first page, it's all the nomenclature. And as I mentioned before, it's an entire series. So you'll see both flanged, flangeless, square, round, adjustable, and then also wet location, which is interesting. And then of course, on the last page, you'll see the overall dimensions of how it actually can fit into what is typically a very minimal real estate plenum depth. So with that, I'd like to bring it over to see if there's going to be any questions. And I think
there are actually, Peter, thanks. There's a few in the queue. Going back to the track, incidentally, there was a question about getting the UGR information. If you're doing a well job, is it available to get candela per meter squared, et cetera?
it is. So all of that is just approach us here at the factory. Please approach all the Oblaney Rinker team as well. And whatever is not published on the website, we'll be able to make sure that either from the Oblaney Rinker team and I, with our support, get you whatever information for all of those interesting characteristics that come up,
All
like
right.
weeds and well and all of that.
Further to the track, the question was, does the wall wash have a cutoff snoot on it?
It's a great question. It does. However, it's still being cooked in the kitchen. So what we're trying to do is assure that that half snoot that would go onto that wall washer does not restrict any of that actual beam angle for side to side. So the challenge of what we're doing is anytime we put on accessory, that's going to have an impact on the overall angle or actual true spread of what's happening with that beam angle. We found with our half snoot first prototype in our rapid prototype program, actually that it restricted the light too much. So it's still in development. However, there are renderings that are available. There is a actual catalog number for any projects that need to be spec'd out right now. And the intent of how that's going is it'll just be a little bit more of a shallow half snoot, almost like a quarter snoot. And what we're doing is assuring that any of the guests in the space or the gallery or the museum on the side of the fixture that is not going to get any glare, that scoop is really going to achieve that glare-free install. But to that end, make sure that it has a broad brush of the light on the vertical surface.
And I think what I'd like to do is also for anyone who's that interested, please contact us if you'd like to get a sample. I know Peter's very big on making sure, just as we are, that you get a sample in your hands, see how it performs, and if it is exactly as great as you think, or might be other. So, and that's the whole point of getting samples. So good with that. I think you answered the question about trimless and mud in. You did show that you already have the mud in adapter.
Yep.
And
we have really nice ball plungers on there to assure really snug and both tactile and audible positive connection when it's in place.
Okay, so then thank you for that. Very comprehensive, a fully developed line, quick delivery, and have gun will travel. That's what I want to say about that. Thanks for sharing that with us, Peter.
Thank you
And
very much.
now for the Aura Odyssey Challenge. It continues. We challenge 3 design firms to accept a blind challenge, similar to our first 2 Chit Chat challenges. They agreed to receive a box with miscellaneous components and a mission to fulfill. The 3 teams have received their boxes, and here is the third and last reveal with HLB lighting design. I'm sure you're going to enjoy what you're about to see. Take it away, Carl.
So welcome everybody. Our theme is energy and sustainability. And we welcome you to our office, which is 3 kph, because that's the minimum power that we need in order to generate energy. Our area of focus was the wind turbines, and more specifically, the vertical axis wind turbines. We are using the wind turbine concept in order to convert the kinetic energy and the person's airflow and movement into the space to generate power.
Energy. I mean, it was like that closed loop system that we just generate it for ourselves, and that wind kind of source of energy versus any other source.
And we would also want to have in our lobby design, like the ceiling parts continue as a furniture piece and create a closed loop. So everything is all together organic and creates a new experience for the occupant. The Hard Lights LED series from Dado Lighting. And what we elaborated is a free line series, which is a freestanding illumination piece.
Because they're so like slim, their profiles are so slim, it made it easy to make it part of the, I mean, like like Eliana said, it became the partition and how you kind of are guided through the space, and it's not clunky and in the way, it just kind of like nicely fits into that.
So here is our diagram for to indicate the motion and for the step line series. So you can see that if we have low activity and not enough occupants are in the space, we would need more airflow. So the LEDs are blue, and as the activity is higher and higher, they turn into purple, and that means that no additional power is needed and we are good to go. Don't worry, you don't need to run in the space if we need additional airflow. We don't need much to create the power. All the materials are recycled, and because there is no such gravity as here, we are using recycled paper as a furniture. We are using reclaimed wood flooring, and the walls are made out of cork. And we are having all the lights and the light parts could be recyclable. Because they have many custom options, it was easy for us to move forward and think that way. And the RGB helped the step line, the smaller pieces, so everything worked.
And we are tremendously thankful to Dado Lighting for sponsoring that. We're tremendously thankful to HLB for participating. And be on the lookout as we are starting our next Chit Chat Challenge to continue to search and help the future of mankind. I did want to go back to one question in the queue before we wrap it up. And that was on the wall wash. Peter, are baffles available as well?
Great question. Not currently. So that's going to be in the same category as the half or quarter snoot for the baffles. We want to keep an eye on glare to assure it's minimal,
Sure.
but also don't want to restrict the overall coverage that the T80 wall wash will be able to perform to.
Gotcha. So please ask for samples. We're big on samples, and that completes our shorts for this hour. As a reminder and a courtesy to you and your time, we really appreciate your feedback. And if you have any at all regarding what day of the week we do these, the time of day, we'd like to hear from you. Please email questions@orashorts.com. Also, our library of Aura Shorts is available 24/7 for your reference on the O'Blaney Rinker Associates YouTube page. We also keep a Pinterest page stocked with fresh images and inspiration from our partner manufacturers. So please check us out there as well. Mark your calendars. Our next edition of ORA Shorts is May 6th. It'll be a surprise. Until then, thank you very much for joining us. Marty, thank you for a very wonderful presentation. Peter, thank you very much as well. Always great to see you. And everyone, please take good care and stay safe. We'll see you next time.